Welcome to Honors Geometry Lesson 5.3, Angle Bisectors. I won't spend a whole lot of time on the definition of an angle bisector because I think you know that the definition of an angle bisector is a ray or a line or something that cuts an angle into two congruent parts. So there's the definition. Guess what? Here comes the theorem. Woohoo! Uh-oh. I must have the wrong page. Oh, there it is. It's right there. There we go. The angle bisector theorem. It says if a point lies on the bisector of an angle, then it is equidistant from the two sides. So here we are. The red line is an angle bisector. How do you know it's an angle bisector? Because the two arc marks show you that these two angles are congruent. So any point along this red ray is going to be equidistant from the sides. And when we talk about equidistant from the sides, we have to measure those perpendicularly. We have to be perpendicular here. That's how it's equidistant from the sides, perpendicularly. We don't want to try to measure off that way. That's not perpendicular, or that way, or that way, or that way to measure to get to the side. We want to measure perpendicularly. So here you go. Okay. The angle bisector theorem says that these two segments are congruent to each other. All right. So, if this right here, if this segment right here is 9, how big is that segment? Right. That would also be 9. Okay. How about if this segment was x plus 3 and this segment was 52? Okay, what would you do? Well, you just set those two equal to each other and find out that x is 49. That's simple. Alright, guess what? This also has a converse. The converse says, the angle bisector converse, if a point is in the interior of an angle and is equidistant from the sides, then it lies on the perpendicular bisector. So AC, because C is equidistant from the sides, AC will be perpendicular bisector. Which leads me to a third theorem. The angle bisectors of triangle intersect at a point. They are concurrent. Okay, there's that term again. Told you were going to be hearing that a lot this chapter. That point of concurrency is called the incenter, and it is equidistant from the sides of the triangle. So here we have a perpendicular angle bisector, here we have an angle bisector, here we have an angle bisector. Those three angle bisectors meet at this point right here that's called the incenter, and it is going to be equidistant from the sides of that triangle. Those three red segments are going to be the same size because that point is going to be equidistant from all three sides. The reason it's called an incenter, you can draw a circle. Well, not with that you can't. You can draw a circle that goes around the inside of the circle, inside the triangle, and hits all three sides like that. That's why that point of concurrency is called the incenter. So I'd like to show you how that looks with a real circle, because that's not a real circle. And there it is. That incenter, used as a center, draw all the way around. Hits all three sides. It's equidistance from the sides. This will end Honors Geometry Lesson 5.3, Angle Bisectors.